Okay, sorry, I just deleted this and had to start over. So, multiplication principle, talking about how many ways can something happen. So, if there are m ways that one task can happen and n ways that another task can happen, then I just want you to know that there are m times n ways that that can happen. You just multiply them together. So, what does that mean? So, it says 3 roads connect town A and town B, and 2 roads connect town B and town C. How many ways can a journey from town A to town C via town B be completed? I was trying to do something with this and I just kind of screwed it up, so just ignore that box, okay? So using this multiplication principle, 3 roads connect town A to town B, and 2 roads connect town B to town C. So multiplying them together, there are 6 different ways that can happen. That's what the multiplication principle is. So how can we show that that's really working? Well, think about if you have town A and there are 3 roads that connect that all to town B, right? So this would go to town B, and this would end up in town B, and this would end up in town B. And then from town B, all of those are town B. Each one of those, there are 2 routes, right? So this leads to town C, 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 and this and this. And you can see if you add all of those ways, that's 6 ways. So like you could go this route and then this route, or you could go this route and then this route, or you could go this route and then this route. And you can see that each one of those is a different way. And so that makes 6 different ways that that can happen. Okay, really big numbers, you're not going to want to make that tree diagram. And so that's why we can use the multiplication principle. So I left that space up here for you in case you wanted to write that. But same idea. It says diners at Angelo's Spaghetti Bar can select their entree from 6 varieties of pasta with 28 choices of sauce. That's a lot of sauce. How many such combinations are there if you only choose one type of pasta and one type of sauce? So this one, I don't want to make the tree diagram out because that's going to be a lot of numbers. But if you want one type of sauce or pasta from 6, so that's 6 types of pasta from 28 types of sauce. And so then you just multiply those together. So you get 6 times 28, and you get that there are 168 ways that you can order pasta at that restaurant. And that's where if you go to like Subway, they always talk about how many different ways you can order a sandwich. And that's because they take all the options for bread and cheese and meat and toppings and condiments. And then that's how you get so many different ways. So what if there's more than 2 items? And so it just says generalized multiplication principle. It just says like given task 1 and task 2 and task 3 and task M, you really just multiply all these together. So I can't even get this to go away. So instead of just M times M, you can say you take the number of ways task 1 can happen times task 2 times task 3 all the way to the last task that's there. So again, another example here says a coin is tossed 3 times and the sequence of heads and tails is recorded. How many possible outcomes are happening? Well, what's happening is we have 3 coins, right? 1, 2, 3. How many outcomes do we have on the first coin? 2. Heads or tails. Heads or tails on the second coin. Heads or tails on the third coin. And so that gives you 2 times 2 times 2, or 8 total ways that you could flip a coin 3 times and see what happens. So again, let's talk about what that means. So how could we write out all the options that's happening there? Well, for coin 1 could be heads or tails, right? And then coin 2, each one of those could be heads or tails. And then the third coin, each one of those could be heads or tails. And this could be heads or tails. And this could be heads or tails. And this could be heads or tails. So again, 2, 4, 6, 8. Like if you wanted to write all the options, like following this line, it could be all 3 heads. It could be follow it to the T. It could be heads, heads, tail. Starting, I'll try to change colors here so you can see where I'm following. Like starting this line now, heads, tail, heads. and heads, tail, tail. And then what if the first one is a tail? Tail, heads, heads. Again, I'm just following this line here. Tails, heads, tail. And then tails, tails, heads. And then the last option would be tails, tails, tails. And again, 1, 2, 3, 4, 5, 6, 7, 8. As we get closer to doing probability, it's really important that we can think about the number of ways that something can happen. Okay? I think that's, I got one more. So it says a combination is unlocked by dialing a sequence of numbers, first to the left, then to the right, and then to the left again. If there are 10 digits on the dial, how many combinations are possible? So this one, you got to think about the number of things that are happening. You have 3 different numbers, right? So I would set this up the same way that I did the last one here. So we have 3-digit combination. It doesn't matter that it's to the left and then to the right and then to the left again. It's just 3 different numbers. So how many numbers could be in the first one? Well, all 10 of them could be the first one. And then all 10 of them could be the second one. And then all 10 of them could be the third one. And that could be like a combination of 777, right? And so that would be 1,000 different combinations. Think about most combination locks have more than 10 numbers. So there's a lot more combinations to choose from there. But then we want to think about what if there's a restriction. So it says how many combinations are possible if no digit is repeated. So on this one, there are still 10 combinations possible for the first number. But once you pick the first number, how many are left? Only 9. And then how many are left? Only 8. And so that one's going to have less options because we can't repeat, right? So that one's going to only have 720 ways if no repeating numbers are allowed. Okay, so we're going to work on this. That's all I have, and then we'll do some in class, okay?